Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.6. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.6. Find the value of voltage V0 in given below figure using nodal analysis. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 1 kilo ohm resistance labeled as V0 using nodal analysis. So without wasting time, let's proceed towards the solution. We know that in order to apply nodal analysis technique on a network, we have to follow some steps. First step includes to count the number of nodes present in that network. In this network, there are 4 number of nodes. Out of 4 nodes, one is reference or common node. Other 3 nodes will be used to apply nodal analysis. In second step, we have to label all node voltages. So voltage across these 3 nodes are labeled as V1, V2 and V3. In third step, we have to label all unknown branch currents along with their directions. In this step, we have marked all unknown currents along with their directions. Current through this branch that is labeled as IA, it is already given in this scenario and it is flowing from node V2 to V3. This network includes 3 number of nodes for nodal analysis, so it will have 3 node voltage equations. We have to find these node voltage equations. We will start from this node. On this node, only one current is entering while remaining all currents are leaving. Entering current is the current of this dependent source that is depending upon the value of this branch current labeled as IA, and the value of this dependent current source is 2 times IA. So Kirchoff's current law equation for this particular node will be entering current is taken with positive sign while leaving currents are taken with negative sign. In next step, we have to find these 3 currents equations and replace these variables with their respective equations. Current I1 will be equal to voltage across this 3 kilo ohm resistance divided by the value of resistance. So V1 voltage is appearing across this 3 kilo ohm resistance. So the value of current I1 will be V1 divided by 3 kilo ohm. Similarly, current I2 is flowing from node V1 to V2. So it is indicating that voltage V1 will be on higher potential than voltage V2. So the value of current I2 will be equal to the potential difference of these 2 node voltages divided by the value of resistance. I2 will be equal to V1 minus V2 divided by 6 kilo ohm. Similarly, current IA is flowing from node V2 to V3. So the value of current IA will be equal to V2 minus V3 divided by 2 kilo ohm. Now we have replaced all these current variables with their respective equations. In order to solve this equation, we have to omit all denominator values. The highest value in denominator is 6 kilo ohm, so we will multiply this equation on both sides with 6 kilo ohm in order to omit all denominator values. Product of 6 kilo ohm and 2 into V2 minus V3 divided by 2 kilo ohm will become 6 into V2 minus V3. Product of 6 kilo ohm will cancel out with 2 kilo ohm in denominator. Only 3 will left and that 3 will multiply with 2 and it will become 6. Similarly, here product of 6 kilo ohm will cancel out with 3 kilo ohm in denominator. The answer will be 2 and that 2 will multiply with V1. It will become 2V1. Here product of 6 kilo ohm will cancel out with 6 kilo ohm in denominator. Only V1 minus V2 will left. And at the end product of 6 kilo ohm and 2 milliampere will result 12 volt. Now open these brackets. Product of 6 and V2 will become 6V2 minus 6V3 minus 2V1, and this minus will multiply with variables inside the brackets. It will become minus V1 plus V2 minus 12. Now place minus 12 volt on the other hand side of equal to separate it from variables, and add all same variables and write equation in ascending order. The equation will become minus 3V1 plus 7V2 minus 6V3 equal to 12. We cannot further solve this equation, so we will leave it for now and label this equation as equation A. This is the first node voltage equation of this network. Now we will move towards second node. On this node only one current is entering, that is I2, while two currents are leaving, one is I3 and other one is IA. So Kirchoff's current law equation for this particular node will be I2 is entering current and it is with positive sign, while leaving currents are I3 and IA and both are with negative sign. In next step we have to replace these variables with their respective equations. Current I2 is equal to V1 minus V2 divided by 6 kilo ohm as we have calculated in previous step. Similarly, current I3 will be equal to voltage across this 6 kilo ohm resistance, that is V2 divided by the value of resistance V2 divided by 6 kilo ohm. And current IA is also calculated in previous step, that is V2 minus V3 divided by 2 kilo ohm. Now in order to further solve this equation, we will multiply this equation on both sides with 6 kilo ohm. The equation will become V1 minus V2 minus V2 minus 3 into V2 minus V3 equal to 0. Here product of 6 kilo ohm is cancelled out with 6 kilo ohm in denominator. Same case is applied here. And here the product of 6 kilo ohm is cancelled out with 2 kilo ohm in denominator. Only 3 is left and that 3 is multiplied with V2 minus V3. Open these brackets. 3 will multiply with variables inside the brackets. The equation will become V1 minus V2 minus V2 minus 3V2, and this minus will become plus 3V3. And all of these are equal to 0. Now arrange the equation. The equation will become V1 minus 5V2 plus 3V3 equal to 0. And this equation cannot be further solved, so we will leave it for now and label this equation as equation B, and it is the second node voltage equation of this network. Move towards the last node of the network. On this node, two currents are entering. One is 2 milliampere and other one is IA, while only one current is leaving, that is I4. So leaving current is taken with negative sign, while entering currents are taken with positive sign. Now we have to replace these variables with their respective equations. Current IA is equal to V2 minus V3 divided by 2 kilo ohm. Similarly, current I4 is equal to voltage across this 1 kilo ohm resistance V3 divided by the value of resistance 1 kilo ohm. Now in order to omit denominator values, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 2 kilo ohm in denominator will cancel out with each other. Only V2 minus V3 will left. And product of 2 kilo ohm and 2 milliampere will result 4 volt. Milli will cancel out with kilo. Here product of 2 kilo ohm and V3 divided by 1 kilo ohm will result 2 V3. Now place this positive 4 volt on the other hand side of equal and arrange this equation. The equation will become V2 minus 3 V3 equal to minus 4 volt. This equation also cannot be further solved, so we will label this equation as equation C, and it is the third equation of this network. Up to this point, we have calculated 3 node voltage equations for this particular network. Now we have to solve this equation in order to calculate this node voltage V3, that is equal to V0, because this voltage is appearing across 1 kilo ohm resistance and V0 is also voltage across 1 kilo ohm resistance. In order to solve these equations for voltage V3, first of all we will multiply this equation B with 3. The equation will become 3V1 minus 15V2 plus 9V3 equal to 0. Now we will add equation A with this resulting equation. This plus 3V1 and minus 3V1 will cancel out with each other. Minus 15V2 plus 7V2 will result minus 8V2 because large value have minus sign along with it. Similarly, plus 9V3 minus 6V3 will result 3V3 equal to 12 volt. We have retrieved an other equation which includes only two variables. Now, in order to calculate the value of voltage V3, we will multiply this equation C with 8 and add that resulting equation into this equation. So, the product of 8 with this equation C will be 8V2 minus 24V3 equal to minus 32 volt. Now we will add these equations together. Minus 8V2 and plus 8V2 will cancel out with each other. Here subtract 3V3 from 24V3. The answer will be minus 21V3 because large value have minus sign along with it. Similarly, 12 volt minus 32 volt will result minus 20 volt. Now, in order to calculate the value of voltage V3, we will divide on both sides with minus 21. So, the value of voltage V3 will become 0.9523 volt. And actually, this voltage V3 is equal to V0 because it is appearing across 1 kilo ohm resistance. So, we can say that voltage V0 will be equal to 0.952 volt. This was Chapter 3 Learning Assessment E3.6. Thank you. See you again in next video.